Hi, algebra students. Today we're going to be working with solving absolute value equations. I'm going to go ahead and share my screen so that you can see the presentation. You're going to need some paper handy and your student journal handy, and we're going to go ahead and go through this presentation. So hopefully you can see the screen. So it says on a sheet of paper, complete each of these. Remember that these bars mean absolute value. We talked about this last week. Absolute value, again, is how far a number is from 0 on a number line. So go ahead and try these on a piece of paper. Pause the video and we'll come back and check. Okay, welcome back. I'm going to grab my pen and we're going to go through these. So this first one, I start by simplifying inside the absolute value. 3 minus 7 is -4. So in this case, it's asking, if I can get my pen to work, maybe -4. Let's turn this back on. There we go. Absolute value of -4. And over here we have 4. And the question is this greater, less than, or equal to? Well, if I look at this, remember absolute value means the distance from 0. So -4 is 4 units away from 0. 4 is 4 units away from 0. So in this case, I should have equals. Let's look at the second problem. Absolute value of -7 is 7, right? It's 7 units from 0. Minus 3. So on this side, I'd have a 4. On this side, I just have -10. Which of those is greater? They're not equal this time. 4 is bigger than a -10, so I should have greater than. Question number 3 asks, what number could x be replaced with to make this true? So what numbers have an absolute value of 5? Well, definitely 5, right? Absolute value of 5 is 5. And what else is 5 units from 0 on a number line? Well, that would be -5. Both of those work. So the values of x that would make this true would be x equals 5 and x equals -5. And a lot of times you'll see that written as a shorthand of x equals, and they use this symbol, plus or minus 5, which means positive or -5. All right, let's look at our next slide. So we're going to talk again about absolute value. Absolute value of a number is its distance from 0 on a number line. This says the graph of the absolute value of x equals 2 would look like this, because both -2, let's go back, because both -2 and 2 have an absolute value of 2. They are both, let me grab my pen here, they are both 2 units away from 0 on a number line. +2 is 2 units from 0, and -2 is 2 units from 0. The solutions of the absolute value of x equals 2 are x equals 2 and x equals -2. So go to our next slide. So in this point, it says to complete the explorations 1A, 2A, 2B, and 2C in your journal. See if I can move me out of the way there, maybe. Go ahead and do those. Pause the video, try those explorations, and come back. I'm not going to go through them, but if you look at the copy of the worked out student journal pages in your notes, you can see the solutions to the explorations. All right, let's move on to the notes. Please add this to the communicate your answer section, number 4, on page 18 in your student journal. The question is, how can you solve an absolute value equation? There are 3 steps. Step number 1, isolate the absolute value. Step number 2, you're going to write 2 equations to replace the absolute value problem. And step number 3, you're going to solve those. Pause the video and write down these 3 things in the communicate your answer section on page 18 of your journal. You have some vocabulary to write down in your journal today. This is on page 19. Please pause the video and copy down these definitions into the vocabulary section on page 19. All right, an absolute value equation is an equation that contains an absolute value expression. An extraneous solution is an apparent solution that must be rejected because it doesn't satisfy the original equation. So sometimes when you solve these, you'll get an answer, but when you plug it back into the original problem, it doesn't work. And we call that an extraneous solution. I would like you to copy this problem down into the notes section at the bottom of page 19 in your journal. So go ahead and pause the video, copy it down, and we'll go ahead and go through it. All right, so we're going to solve an absolute value equation. If you recall from the previous page, we said in order to solve an absolute value equation, the first step was to isolate the absolute value. So I'm going to grab my pen. And my first step to isolate, to get this absolute value all by itself, is to add 5 to both sides. So far it seems like just solving a regular equation. Don't forget though that this does have absolute value around it. So the question is, the absolute value of what number is equal to 8? Our next step after we've isolated the absolute value is to write 2 equations and solve them. So one equation looks like, well, just like the original, without absolute value, x equals 8. But the other question is, remember this number inside here could be a negative 8 because its absolute value would also end up to be 8. So I have the equation x equals negative 8. Now, the next step in the procedure said to solve these equations. Our equation is already solved. So these are our 2 solutions, x equals 8 and x equals negative 8. I can plug them back into the original to make sure they work. So let's try positive 8. The absolute value of a positive 8 is 8, and 8 minus 5 is 3. So that one works. I take negative 8. Negative 8, the absolute value of negative 8 is also 8 because negative 8 is 8 units from 0. And again, 8 minus 5 is 3. So both of these are solutions. So we write them both on our paper. All right, let's look at our next slide. This time you're writing this problem in the notes section below solving absolute value equations on page 20 in your journal. So please locate the notes section below solving absolute value equations and copy this example into your notes. Go ahead and pause the video and copy it down. All right, so this time we're going to solve this equation and we're also going to graph the solution on a number line. So I'm going to grab my pen. I'm going to go back. Let's try getting a pen this time. There we go. So again, first step is to isolate the absolute value. If I look at this case, the absolute value is all by itself on the left side of the equation, so I don't have to worry about isolating it. The next step, however, is to write 2 equations. So one thing I like to do is I like to think about, well, I'm going to cover this up. If I didn't have anything here, and it's kind of hard to do this with video, but if I cover this up, I'd be asking myself, what number can I take the absolute value of and have it be equal to 4? Well, the number inside here could be a positive 4. So that would mean x plus 3 would have to equal 4. But it could also be that this number inside here is a negative 4 because the absolute value of negative 4 is also 4. So my other possibility for what x plus 3 is negative 4. So I'm going to solve both of these problems. And I'm going to go and solve them just like regular equations, one-step equation. In this case, I subtract 3 from both sides, and I'd get x equals a positive 1. In this case, I subtract 3 from both sides, and I get x equals a negative 7. All right, we can check and see if that's true. What's 1 plus 3? 4. Absolute value of 4, 4. Let's try negative 7. Negative 7 plus 3 is negative 4. The absolute value of negative 4 is also 4. So our solutions in this case are x equals 1 and x equals negative 7. So I'm going to graph those. I put a dot at 1 because that's one of my solutions. And I put a dot at -7. What's interesting about this, and I'm going to switch colors here just so you can see what happens, is that when I have those, if I try to find the point halfway in between those, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So halfway in between there is this number, -3. If I look on this side, how far is -7 plus from -3? It's 4 units. If I look on the right side, how far is 1 from -3? It's also 4 units. And that's translated right here in this problem. This is asking you what numbers whose distance from -3 is 4 units. If I go 4 units to the right of -3, I'm at 1. If I go 4 units to the left of -3, I'm at -7. All right, let's look at another problem. This is extra practice, page 21. It says solve the equation and graph the solution. So again, I want to know what numbers could replace this and end up with a +8. So remember, the absolute value of a +8 is 8, and the absolute value of a -8 is 8. So I'm going to write my two equations. So one of which is y plus 2 equals 8, or it could be that what's inside y plus 2 equals -8. Notice I don't change the signs of anything that was in the absolute value. I keep it just like it is. The only thing I'm changing is whether or not this value is a +8 or a -8, because both of those have an absolute value that's equal to 8. So next step is to solve both equations. I'm going to subtract 2 from both sides. So this first equation, I get y is equal to 6. The second equation, I get y is equal to -10. To graph the solution, it's 2 points you're going to put on a number line. 1 point is going to be at -10. So just put a dot at -10 in your number line. And your other point is going to be at a +6. Again, let's look at where we started. This time we were looking for numbers whose distance from -2 this time was 8 units. And let's see if that's true. If I go from -2 all the way up to 6, I've gone 8. If I go from -2 down to -10, I've also gone 8 units. Okay? And that will be the case when you solve these absolute value equations, that these solutions you get are the same distance from your starting point, in this case, -2. Now let's look at another one. Okay, solve the equation and graph the solution. So it could be that what's inside, again, let's grab a pen. It could be that what's inside is equal to a +3, or it could be that what's inside is equal to a -3, because the absolute value of +3 is 3, and the absolute value of -3 is 3. So let's switch our color here, because we're going to use a little, let's go, ooh, I think magenta. All right, to solve this problem, we have D being divided by 3. The opposite of division is multiplication. Multiply both sides by 3. My 3's cancel on the left. I end up with D equals 9. And on the right, I multiply both sides by 3 again over here for this problem. And this time I get D is equal to a -9. So our solutions this time are +9 and -9. All right, let's look at our next problem. All right, it says to complete problem 26 on page 32 in your textbook. use your warm-up paper to write the problem and show your work. So go ahead and pause the video and try it, and then we'll work it out here. All right, so on page 32, number 26, we have the problem with the dogs. It says the shoulder heights of the shortest and tallest miniature poodles are shown. The smaller dog is 10 inches and the taller dog is 15 inches. So it says represent these two heights on a number line. So I need to represent 10 inches and 15 inches on a number line. Let me grab a pen. All right, so I'm going to make a number line. It's beautiful. So this is 0. And the two numbers I'm writing down are 10 and 15. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15. All right, so that's part A, says represent these two heights on a number line. Then it says write an absolute value equation that represents these heights. So I need to find, first of all, where's the halfway point in between these? So they are 1, 2, 3, 4, 5 units apart. So I'm going to count 2.5 units. So 1, 2.5. So halfway would be right in the middle, which would be at 12.5 or 12.5. Then to get to that, I counted up 2.5 units or 2.5. 12.5 to 15 is also 2.5 units. So my absolute value inequality would look like numbers whose distance from 12.5 is equal to 2.5. Okay, that one was kind of tricky. If you didn't get that one, it's okay. We'll work on those some more in the future. All right, let's look at our next slide. Our next slide is the assignment. This assignment's in your book again. Remember, there's a link to the textbook in Schoology. Go ahead and do these problems on page 32, problems 3 to 20 and 26. Good luck, and I'll see you next time.